So for number 4, water is pumped into an underground tank at a constant rate of 8 gallons per minute. All right, so it's pumped in at 8 gallons per minute. Water leaks out of the tank at the rate of square root of t plus 1 gallons per minute. So that rate is changing with time. And this is going to be going from t equals 0 minutes to t equals 120 minutes. And then it tells us at time 0, we start off with 30 gallons of water in the tank. Part A asks us how many gallons of water leak out of the tank from t equals 0 to t equals 3 minutes. So over that time span, we want to figure out how much is leaked out. Well, for problems like this and other ones that we'll see, if we're given a rate and we want to find out how much has occurred over an amount of time, we can use a definite integral. Basically, if we have the definite integral from a to b of a function of t, and a lot of times this might be a derivative, but it's going to be a rate. But it may not be written as a derivative, but it has to be a rate for this to happen. If we look at this definite integral from a to b of f of t, we're looking at the change from t equals a to t equals b. Right, from this time period to this time, we're looking at how much it's changed. Most common one that we looked at was like displacement. Right, we did the definite integral of velocity from a to b. We're looking at the displacement from a to b, how the object moved. So here, similar scenario, we have a rate of square root of t plus 1 gallons per minute. If we want to figure out how many gallons have leaked out from 0 to 3, we're doing the definite integral from 0 to 3 of square root of t plus 1 dt. So we can use u substitution here. U is going to be t plus 1, so du is just dt. So really not much changing there. But we are going to change the a and b. If we put 0 in for t, we get 1 out. Put 3 in for t, we get 4 out. And then we're left with square root of u du, or u to the 1/2 du. What's the antiderivative of u to the 1/2? Two-thirds u to the 3/2, right? Add 1 to the exponent, then multiply by the reciprocal of the new exponent, or divide by the exponent. And we're evaluating this from 1 to 4. So I'm going to leave that 2/3 out in front. We get 2/3 times 4 to the 3/2 minus 1 to the 3/2. So 4 to the 3/2, remember that just means we're cubing it and taking the square root. The order in which we do that doesn't really matter. I'm going to do the square root first. Square root of 4 is 2, and then 2 cubed is going to be 8. Square root of 1 is 1, 1 cubed is just 1, so we have 8 minus 1. We end up with 14/3 gallons.